Hello and good morning all. I'm Jennifer and it's my pleasure to extend a hearty welcome to all of you to today's webinar. The topic for today will be opportunities in core engineering with the rise of emerging technologies, which will be presented by Mr. Vibin Aravindakshan. And we have another speaker for the morning, Dr. Ajit Paranjpe, as Senior Vice President and CTO of Veeco, who will be presenting on the topic Trends and Opportunities in Fabrication, Equipment and Materials for Semiconductor Devices. Vibin currently serves as a CTO for the startup Careerbolt, based out of India. Before this, he was a Director of Product Management at Salesforce, heading the Application Security Division and Domain Management Service of the core platform. He has also worked as a Senior Product Manager with AWS and HPE. At AWS, Vibin headed the identity and management services of AWS IoT and launched LoRaWAN network services. At HPE, he led all black box application security product offerings, including the industry-leading web inspector solutions. Before Vibin switched to the product management, he was in core engineering, having worked as a photolithography engineer for Micron Semiconductors. Vibin was involved in technology transfer to a 50 nm nanotechnology, which was a breakthrough technology back in 2008. Furthermore, Vibin worked with Samsung Electronics in Korea, introducing novel technology innovations, including their data analytics-based preventive maintenance platform. Vibin completed his bachelor's in metallurgical engineering from IIT Madras and master's in material science and engineering from MIT and an MBA from Georgia Tech. We're very happy to have you with us, Mr. Vibin. Let me introduce our next presenter for the morning, Dr. Ajit Paranjpe, who will be presenting over the topic, like I said again, trends and opportunities in fabrication, equipment, and materials for semiconductor devices. Dr. Ajit retired as Senior Vice President and CTO for Veeco. He has over 30 years of technology development and senior management experience in the semiconductor capital equipment industry. As a CTO, he drove Veeco's organic growth initiatives in photonics, RF GaN, micro LED displays, MRAM, and advanced packaging. Earlier, he led the technology and applications development of MOCVD systems, resulting in product leadership for HP-led markets. He has broad experience relating to the fabrication of semiconductor, optoelectronics, and magnetic thin film devices. Dr. Ajit has co-authored over 50 publications with over 60 issued US patents. He obtained PhD and master's degree in engineering from Stanford University and a BTech degree from the Indian Institute of Technology, Madras. We're very happy to have you with us, Mr. Ajit. And before I hand it over to the speakers today, I would like to let you all know that the speakers will be presenting their respective topics for 10 to 15 minutes each, following which we'll keep the floor open for Q&A. Request all scholars to please keep posting your questions in the Q&A box, and let's have a very interactive Q&A discussion today. Over to you, Ajit and Vibin.
So a quick summary again about me. I think the key points I want to highlight is that I have both had a core engineering from a material science perspective background and also a software background. So it should be interesting for people today because they do see a lot of trends that are from the world of software disrupting the normal core engineering work. I've done pretty crazy stuff. So traditional engineers would just do a process and lithography or process work. I did a couple of math work, couple of interesting things, which might be interesting for a lot of folks. The key point I want to make for everyone is career is what you want to make it out to be. So if you look at my career, that's pretty much where it has gone. Okay. So moving on. The topic was opportunities in emerging technologies. So I just want to give a quick summary of what's happening, at least what people should be seeing of late. There might be 100 different other things that of course pop up relevant to people's field of study. Chemical engineers, civil engineers might see very different things that are on top. But these are some of the common things that seems to be like ramrodded down everyone's throat these days, right? Everyone is talking about AI, everyone is talking about big data, cloud computing, and a bunch of other things, AI, VR, 3D printing. It just goes on and on. Name it, you'd find one of those things over here. So hearing all these technologies, the key thing, I guess, for a student's perspective is, why should I care, right? You're going to be thinking about in two perspectives, right? There is going to be related to existing roles. You're going to think, hey, what's going to happen to my existing roles? Are there going to be enough jobs out there in the market? Is the world of engineering going to be redundant, or is it going to be absolutely disrupted? That's always a question. So it has been the same since, I don't know, time immemorial. Since the advent of technology, people are always worried whether their livelihood is going to be like out and they're going to be out in the streets. And it's going to happen again. So that question is always going to remain. But I'm going to give some general thoughts or suggestions, and then we can carry it forward from there. There are also a bunch of students who would be interested in these technologies. These are just not keywords to them, right? They're going to be interested in, say, applications of ML or applications of, let's say, nanotechnology, and they're wondering how does a career that they've been trained for by universities, which are pretty much 10 to 15 years behind on the curve in terms of technology, gonna impact how they're gonna be ready for the job market and how they're gonna make a fit, or what should be they doing, what should be the opportunity they should be looking for, right? So you're gonna think about that, and then you're gonna think about like, how does it affect me, right? Like, how does it affect, what should I do? I think these are the key two things every student must be thinking. If you're not thinking on it, you should start thinking on those lines. Okay. So let's take the first thing first. So going to the point of how will it impact me? I guess the key thing to understand is if you're an engineer, the world of engineering is pretty like stable. The technologies don't come just thrown from a lab to the real world. There's a maturity curve. It takes time to get out there. And also the fundamentals of engineering are pretty much like bolted down and secure. So if you look down, this is the case 100 years in the past. This will be the case 100 years into the future. It is a case today, of course, where most of the jobs are they're going to be stable. They're going to be related to your core field. So if you are an engineer, you're graduating, it's going to be it's a process engineer, a device engineer, maybe an R&D engineer, but it's going to be related to your core field. So if you're a material science engineer, you have done work in semiconductors, you better have your fundamentals of semiconductor industry really really solid, right? So whether it be photolithography process, it's going to be vapor deposition process, or physical deposition process, or like etching, whatever it is, it better be solid over there. You understand the process. You better have experience related to what you have done, so you can actually go ahead capitalize on it in industry. But the industry is going to function pretty much the same way. For most engineers, the job is not going to change. Even R&D engineers, they're going to worry about how do I bring in new materials. The process is laid out. It's a very standard process, and it is well vetted, and you'll go through the same process. So those kind of processes will continue. So first, the key thing to think about in your mind is 90% of jobs out there, even if it is for a software engineer is going to be doing jobs related to client servers. So whether it is a client side, server side, that's largely how information is presented today. You would work on those. So fundamentals of industry are exactly as it is, and you would need to go there with that same set of capabilities and awareness. So 90% of your jobs are going to be that's going to be the same, right? There's going to be a few changes, and in fact, those few changes, companies themselves will train you for it, or you can pick up stuff. So as long as you have ability to learn, you keep yourself flexible, you can get those things. So think in those lines that, hey, is your job uncertain? There may be downturns. Everybody goes through downturns. Market may not be taking in students at this point of time, but don't worry too much about like, hey, is a job X going to remain? A civil engineer job is going to remain. You better be comfortable with your fundamentals. And if that is a direction, it's going to be a fantastic career for you. Okay? But where does the change happens? So with new technologies, there are going to be new job roles that open up in R&D. Okay, we'll go through a few of what that means. So when technology innovation happens in one field, the impact of it is felt in across all fields. So you would see new ways of doing things. You'll have new opportunities to do research. And if you're kind of person who likes to be in the cutting edge of work, if you call it the cutting edge, you will always find opportunities in that direction. So there will be new jobs created. There'll be exciting jobs, and we'll go through quickly a few of them. And of course, we can take up more as we discuss. Also, there is going to be jobs at the intersectionality of different subjects. So if you are a person who's just done chemical engineering, should you pick up computer science related knowledge? And how do you merge them both? If you're from pharmaceutical industry and computer science industry, how do you merge both? What are some of the opportunities? That'll come up too, right? Or it could be like materials and civil, right? It could be an intersection of a lot of these things. So again, they are going to be exclusive. They're going to be limited set. They're not going to be like be hired on the scale. So if you're a kind of student looking for those opportunities, understand those opportunities exist, but they'll not be mass publicized or made aware. You'll have to go searching for it, but they do exist and they'll be exciting. Okay, this is impact of, let's talk about the R&D work first. So normally material science deals with things like electronic properties, physical properties. You'd go deep into it. You'd study the materials perspective. And there are a lot of different things that we traditionally do. For example, simulation is something that most material scientists do. It's also the common case when you look at, for say, mechanical engineers or aerospace engineers, where they do a lot of their engineering work based upon simulating how the responses would be. You'd solve a bunch of differential equations, and then you try to simulate how the things would look like. Of late, there has been a disruption with, for example, ML. ML is, it's great. Normally, you wouldn't expect ML to hit the realm of material science. At least I wouldn't initially, but things have changed. So, for example, there is an ANSYS report. If you read a little bit into it, ANSYS is pivoting towards like getting more ML to actually substitute their or complement their simulation work, and it is faster. So, if you talk about simulation that runs in like order of days to actually simulate certain components, you could actually get that over like 20x or 30x faster. So that's exactly the finding with ANSYS. I have a quick video of actually a simulation versus ML neural network model, and you can actually see they're pretty darn close. Like even at slow motion, you can see it's pretty darn close. So the way these technologies work are very different. One solves, under the hood, both of them solve differential equations. One of them looks at solving it for each step, iterating it and try to find out what a change would be over a period of time, versus one looks at data and sees how these boundaries get drawn and then try to predict how a flow would behave on new scenarios. Again, just based upon data that is collected, images that is collected, videos that is collected. Very different approaches. Interesting that the end results would be pretty similar. And in fact, that changes a lot. So if you are in industry and if you want to quickly prototype, would you wait for 20 hours? It depends. It depends on the kind of use case you have. But if you can get something that is order of minutes, of course, it is important to you to recognize that. I have a student who we mentored as part of Careerbolt. He's also from IIT Madras, who actually is working right now in the Berkeley labs, working on exactly these kind of problems. So that is applying ML to material science problems. And the people who would hire him would be people like ANSYS or others. So these kind of research are like cutting edge today, and people are working on it at this point of time. I want to just bring up another case about intersectionality. So when I was working with AWS, which is again totally related to cloud computing, and you would not think how that impacts real businesses out there, not purely from computing sense, but also from how they operate. So this is an example from ExxonMobil. And you can think of the use case like ExxonMobil has those remote oil fields out there that are maybe offshore or they are in remote locations. They're really hard to man. And getting people out there to actually go monitor and fix something takes a lot of effort and a lot of time, right? Sometimes it's not even possible if there is storms and other things out there. So how do you go build a digital twin? Is something like creating a replica of that environment in your lab. So you can see all the data that comes out streams to your lab, where you can actually start visualizing how, for example, a pump is functioning out there, how a tube is delivering certain flow rates out there in the field. And if there is a certain issue, you can worry about, hey, can you go lock it down locally, or do you need to actually send an expert over there to fix certain things? Earlier, the visibility was totally not there. Of course, it comes in layers. You could think of it like, hey, data collection, visibility, and then going ahead and doing some remediation fix. But through the journey, the question remains, how do I get information out there and present it meaningfully for people? And the digital twin is creating a replica of that production environment out there in the field, in the lab environment, such that people can access it, right? How does this impact? So if you are, say, a mechanical engineer, or if you are a material science engineer, you would go ahead and worry about what kind of data are these that you should actually go model in the lab. And you'll also worry about what this modeling means for things like prediction of tool failures and many other things out there in the field. So if you're a mechanical engineer, if you're a material science engineer or chemical engineer, you would need to be involved in such projects. You would need to have a solid understanding, one, of your basics, which is related to your field, pumps, motors, or if you are a chemical engineer, related to flow rates, related to like how reactions happen, and then connect this to the data that is generated. So what is the frequency you collect data? Where do you store the data? How is it secure? What do you need to build there? If you're an electrical engineer, you would worry about things like how does the installation not get hacked? So what kind of security you would build on top of it, right? So it's an entire project that brings in tons of different people with very different skills to actually go ahead and create something that important for the company. So this is again intersectionality, real world project that people like AWS, Microsoft, of course, should be doing the similar stuff, Google too, to actually go make these things happen out there in the market where they disrupt what is traditionally considered as a very engineering role. Okay, now that comes to the final part of this story. We will get any use case, more things that you guys want to discuss, we'll jump into it. From your perspective, if you know these changes, what should you do, right? For existing jobs, I always say the same thing: be ready with your core subjects, revise, be aware, look at the trends. For example, there's a lot of investment into semiconductor from India. You should be thinking about that if you're 4 or 5 years in the pipeline for graduation. What does that mean for you as a software, as a material science engineer or a semiconductor engineer? Be also like job ready, right? So being aware of your subject matter is great, but getting a job is a very different thing. So be aware of how do you prepare, how do you interview, how do you present yourself, how do you get the jobs that you're really interested in, those kind of things. What does that mean for you as a career, right? So be aware of the process and be prepared for it. Be doing that work earlier is better. If you're into that R&D kind of work or looking at the intersectionality of kind of work, you'd of course need to be an expert in it. Nobody wants to hire and then teach people what to do. You better have shown interest, have publications. Like what Ajit has, he has 50 odd publications. You better have a fraction of it out there so that you can actually go demonstrate your value in the market, right? Work with your faculty, do some research, do project work. I have a student who's actually from one of the mentees, right? She actually is in electronics engineering from IIT Dharwad, and she's actually getting into ML in allied spaces. She started working on it 6 months ahead, and she has had a lot of success in terms of projects she want to work with faculty. So again, make your moves 6 months and a year ahead. Be aware of what is happening in the space and go ahead, get real world experiences. Only then can you actually be ready for the market, right? Actively reach out. Jobs are not going to land in your lap. So one of my close friends, he works at IBM Research. He works in now designing materials for quantum computers. It's really a crazy field where like even you don't know what kind of logic gates should fit for a quantum computing device. What does that mean, right? So he's thinking through the same problems with a group of people who too are thinking through the same things. These jobs don't come to you and hire you. If you have enough skills, if you do the reach out and if you find the right people, they actually like say, hey, why don't you come and work kind of thing. So do the reactive reach out, things are not going to fall into your lap. So there's a famous Sanskrit shloka, if anybody can read it, it should be pretty obvious to you, but it is that if you're a hungry, sleeping lion, food does not directly enter your mouth, right? You have to go and do the hunt. So it's the same case, things don't fall in your lap, go do that stuff out there, okay? I'll wind my talk for now and hand it out to the illustrious Ajit. He would have a lot more interesting things to say. But yeah, happy to discuss afterwards and we can carry on with some queries. Ajit, over to you.
Hey, Vipin, thank you very much. I think you provided a very good stage for what I'm going to discuss. My talk is going to be more specific on semiconductor fabrication. I think all of the comments that you made are very valid and apply to that topic as well. So with that, let me share my screen and begin. Well, hello, everyone. Thanks for attending this session. I think Vipin's provided a very good background in terms of how you plan your career and what you should be looking for. I've actually had a very exciting and rewarding and satisfying career for over 30 years in the semiconductor fabrication industry. And I would like to show you some slides to show the excitement continues and that you should certainly seriously look at this sector in terms of core engineering. It provides a number of opportunities. As Vipin mentioned, the jobs are there, job security is pretty good, and there is a lot of excitement, a lot of investment, and I wanted to share with you some of the key points. I'm not going to get into a lot of the technology details. I'll be happy to answer those technical questions in the Q&A session, but I just want to give you an overall view of how this technology and market is progressing. Okay, so if you look at the market, semiconductor market, device market today, in 2023, it's about $500 million, and it's projected to double over the next decade, which is a significant growth. And what's driving this growth is the fact that there's an increasing use of cloud and edge computing for heavy workloads. You're all familiar with generative AI and ML, and that's requiring a lot of workload, not just at the cloud, but also at the edge, because you cannot possibly do all the computation at the cloud if you want to take action at the edge. So some of it has to move to the edge, requires new classes of devices. So the growth is not just due to increase in volume. It's actually due to new technologies, new devices, and increase in volume. So all three factors are coming in, which is driving this huge growth. On the consumer electronics side, you're all familiar with smartphones. The next thing would be the AR, VR application that will grow. And of course, there'll be many more applications down the road. That market is also growing, requiring new classes of devices with new sensors. Healthcare is another interesting area where, of course, the diagnostics, increasingly using electronics. Also, the actual procedural stuff like robotic medicine. And then the biggest part would be personalized medicine, for which a lot of electronics would be used as well. Automotive has been very stable and doesn't change at a fast rate. But if you look at the industry over the last 5 years, it's changed dramatically. Of course, there's the electronic vehicle, where the electronic content of those vehicles is very high, because virtually everything is electronics between the powertrain and the control system and the battery system, etc. But if you look at conventional vehicles, they're adding more sensors. They're going to higher voltage electronics. They're adding new features like drive-by-wire, all of which is significantly increasing the electronic content in vehicles. And then finally, telecom. I mean, if you can generate the data, you've got to store the data, you've got to transport the data, and that's where telecom comes in. It's not just the 5G and next generation 6G that deployments are going to be hearing about, but also the back end, the backhaul has to be improved to increase the bandwidth. So all of this is driving this tremendous growth in semiconductor devices. So this is a pretty stable market, but it's growing rapidly. Now, if you look at what's causing these there's some 5 seismic shifts which the Semiconductor Research Corporation has identified for the next decade. And these are the areas in which there's going to be significant investment and, by definition, innovation is required to advance the technology. First of all, analog is going to become more important as IoT. As Vipin mentioned, IoT is an important element. IoT is being added to many devices going forward. The amount of data that's being generated is just growing exponentially, and there has to be some way of storing the data. So growth in memory technology is another important topic. As I said, the data has to be moved around. So telecom, both in terms of RF and photonics for high bandwidth communication. All the data that is being thrown around, is lost around, has to be secured. Now, not just at the software level, but increasingly at the hardware level, to be able to get the speed and efficiency, power efficiency that's required. And finally, electronics did not consume a lot of the energy demand in the world, but going forward, it's going to become a significant component. So making things energy efficient is vital, because without it, we'll run out of energy. And of course, we will also hit against the limits of the climate change limitations. So these are all the main areas in which there's a lot of innovation that's going to be required going forward. This is a snapshot of how technology evolves in semiconductors. So unlike most industries where you see changes are evolutionary, they're minor. If you look up from one model vehicle to another, you see minor changes. You don't see enormous changes. In semiconductors, virtually at every node, which happens, depends between 18 months and 24 months, you see a discontinuous change in technology, because you just cannot scale the technology linearly. You've got to add new features. And what's shown here is Intel's progression from the 90 nanometer node all the way going forward. And essentially, you can see at almost every node, there is some change in technology. Change in technology means opportunities across the entire value chain. And that means continuous excitement, that's where you can generate papers, generate patents, and actually expand your field. So my career started at something like the 350 nanometer node. So if I try to put all of those on a single sheet of paper, it'd be impossible to read. So it's the same story in my career where I saw many transitions at every node. And this is how things are evolving. Now, the other part is, what is shown is one part of the structure, but the structure is extremely complex. Tens of layers are required to build the final device structure, like is shown here. That was logic, and logic is typically 60% of the dollar, maybe only 40% in wafer volume, but a lot of the technology, advanced technology, first gets introduced in logic. The other area that's growing because of memory demands is, of course, one area is NAND, which is used in flash memory. And essentially this consists. Okay, so I was talking about memory. So memory is also growing at a phenomenal rate. Here you see a 232-layer NAND chip. And there's essentially at every layer, there is a 2D array of memory cells and replicated 232 times. When this technology first came out, depending on the company, it had, it's anywhere from 24 to 48 layers. And you can see in a very short period of time where it's gone to. So the rate of progress and acceleration of technology is just phenomenal in this industry, and that creates continual opportunity. Okay, so moving on. The other area, of course, is packaging. Now, packaging was typically delegated to sort of job shops in Taiwan, et cetera, or in China. But it's evolved significantly because to really drive the industry, you have to have significant increase in compute capacity in a very small footprint. So it started out with very simple devices that were put together using flip chip technology, but now there's a concept of using chiplets, where you take the entire die, break it up into small chiplets, and you integrate them on a substrate, which is similar to a wafer. And you build up a very complex device with memory, I/O, power semiconductors, all kinds of devices, and even maybe optoelectronics to build essentially a telecom network on a chip, optical telecom network on a chip. So this is another area of growth. Actually, India is going to be investing in this. I've heard at least 3 announcements of packaging fabs coming up. And the technology that's used here is probably something more like the 180 nanometer node type technology is good enough to address this. So very much well within the scope of what can be done in India. So what does it take in the ecosystem? So of course, at the spearhead of the fabs, and that's where I started my career. I started my career at Texas Instruments. They're both fabs at companies like Intel, which are called IDMs, independent device manufacturers, and foundries. And TSMC is probably the leading edge foundry. A very large number of wafers being produced. Each fab these days, the leading edge it starts with 10 billion and goes upwards. So it's a very expensive venture. The other big area, of course, is equipment. And the equipment segment itself, between different types of equipment, very complex equipment, many steps are required, is another $130 billion market. And to support all of this, you need materials. So materials are not just your run-of-the-mill materials. There are some of those, but majority of them are specialty materials, many engineered materials. New materials have to be developed all the time to essentially introduce them into these chips. So that's another $70 billion market. So you can see the cumulative market from a job market perspective, end product, is probably going to be 1.5 billion or so, quite easily. And ideally, from a career perspective, I found it's best to go from a fabs, then to equipment, and to materials. And the reason for that is experience, hands-on experience cannot be discounted. This is the most important. So if you're able to build on hands-on experience, broaden your expertise across multiple domains here, you can easily go in very senior roles to these different sectors. And the reason for that is, if you're going to be changing the technology with some discontinuous changes every 18 months, you need to be able to forecast what is required next. And you get that insight only by knowing what didn't work, what did work, and what are the logical choices to make in terms of selections of technology, equipment, etc. going forward. The only way you get that is by actually with a lot of hands-on experience in the fab, learning the hard way. It's a rough world out there in the beginning, but then it's going to pay off handsomely later on. So Vibin mentioned this technology, there are so many different facets to it. So it's not just a core engineering, you need the physical sciences, and it's a full stack process. You've got to basically integrate materials, structures, and you've got to look at it at what's called the holistic solution, where you have to optimize technology and systems, co-optimize them. And that, of course, requires a very interlocked multidisciplinary approach. So you might start out in one domain of engineering, but very quickly you need to diversify your skills across multiple domains and across multiple elements of the stack. And that would provide continual learning opportunities, and learning new stuff and executing new stuff always leads to job satisfaction. And of course, it's also typically financially rewarding as well. So I think, this industry is one where experience counts. Somebody coming new into this domain will lack the experience and cannot compete with an experienced engineer who's really diversified and planned a career. So with that, I'd like to thank you for your attention and hand it back to Vipin. And sorry for the interruption. I didn't even realize that the internet had gone offline.
Folks, I'll just jump back to the question from Neha. So quick high-level thoughts that I have on my mind. Firstly, why do you want to leave core? It's a question for you, from mechanical to computer science. But does it have to be necessarily computer science? Is it related to some intersectionality, like I just mentioned? Could you find some other field within your mechanical engineering space that makes sense for you? Because it's easy to migrate from allied branches rather than switch to something very dramatically different. It takes time and effort and preparation. And ultimately, it should be driven by core interests and not related to small temporal monetary benefits, because world changes, things change. For right now, for example, computer science industry is in a little bit of a hotspot, right? Long-term things all work out, but you better have the passion and drive to do that. But to the question, if you have identified that, coding, you have done some things, maybe you've written a couple of codes. I suggest actually that you start picking up on small things and writing up a few codes to see if it's, for example, you could pull data from LinkedIn and then do some analysis with that, right? It gets you a sense of seeing if coding really life is for you. Coding life is spending 8 hours in front of a laptop, not moving, and then fixing a problem, and then taking 3-4 days off if you're lucky. Or it could be daily 4 hours at a stretch, right? You better be comfortable with those kind of activities. And what does a career in coding mean for you? You'll have to have certain basic things like data structures and algorithms. You should have to be very comfortable with a certain programming language, a technology. For example, let's say front end. I want to do front end web application development. I need to know Node.js. I need to know HTML, CSS, right? Basic things you need to know. If you're in backend, you need to know some sort of like backend technology, Java, C#, right? Just pick that up, right? You need to be aware of different protocols out there, like say some ways in which you deliver APIs onto your, like RESTful ways in which you deliver data onto your customers. So you need to be comfortable. You need to have built projects. You need to be really strong with your fundamentals, and you should need to do it in a very optimal way. You can't, for example, brute force solutions, right? That's a very bad way to build stuff. It works on your laptop, but it never works on real life, because in real life, there are millions of people, both good and bad actors, trying to access things at the same time. So that means a lot of compute memory loads and stuff like that. So to that question, how should I prepare? If you're interested, just find one specific space, start working on it by small projects. You can find material online too to actually build that knowledge. But if that's interesting, only then proceed. Don't do this blind jump of faith saying that, hey, you know what, everybody is jumping into computer science. That's really a disaster, a way for a disaster, right? It could be management that you're really interested in. It could be marketing you're really interested in. Or it could be core engineering, right? Yeah. You really need to figure out what is that makes sense for you. Don't do things because everybody else is saying that's the latest fad right now, because that will not just sustain. I'll stop there.
Thanks, Vibin. So we have a question from Satyam Maurya, who says, I'm a BTech student in mechanical engineering and passionate about digital hardware manufacturing in India. How and what important things should I follow in terms of job and startup?
Ajit, probably right up your alley.
Okay. So unfortunately, not that familiar with the ecosystem in India, but clearly what's happening is the technology gap between India and the West in technology is shrinking. I mean, in the IT industry, it's zero. It's maybe India could also be ahead in some spaces, but in the engineering field, there's still a little bit of a gap. So fundamentally, I think in many of these areas where you try to get into manufacturing, I would say it's really important to build the skill set that's going to be required for that industry. So which means you actually have to learn what's not in India today. You have to learn what's out there in the world, and that's your value add. And the way to do that is, I think Indian institutions, I mean, I've been working with the IITs, and obviously with IISc. The faculty are definitely plugged into what's going on there, and the facilities and capabilities are well within the scope of what's being done up there. So in the rest of the world. So I would recommend, if you want to do that, try to establish a project, work. You almost need an advanced degree so that you can add some new value. If you're going to just go and do a job that somebody else specifies, that might limit your prospects. If you're bringing something new to the table, and that you can do by working at one of these institutes, getting a master's degree, working on a project of industrial relevance. And that makes you incredibly valuable. I mean, some of the students that I've mentored, I've given them some projects and very soon they've got a job because the project is of industrial relevance and the people see that this person is really differentiated. Because if you just look at a resume, it's very hard to differentiate. I find it extremely difficult to differentiate between students just based on resumes. But the moment somebody's done something and can show me what they've done, even they may not be the best, but I know what they're capable of doing. And if they can do what I want them to do, I'm going to hire them. I'm not going to necessarily hire the best. I'm going to hire the person that I think is appropriate for the job and has the highest likelihood of success. So think of it from that perspective, from the employee's perspective, and see what value add you can bring that's differentiated that they don't have today and will essentially give you the entry ticket. I mean, it's not very specific because I don't know the specifics of this industry, but hopefully that gives you some pointers about how to think about the problem.
Ajit, I would like to add to it. Love the fact about learning by doing. In fact, that's probably the only learning you'll ever do in your life, right? So to that student who's talking about the hardware market or trying to build devices in India, right? There are great startups, for example, drone-based startups that are, I can give you a quick names, but there have been a couple of very successful drone-based startups in India. I think Dronacharya is one of the ones you'd have heard, right? Very, very interesting, quirky name. But there are a bunch of projects being driven from like government of India trying to like make it in India program. So if you're not aware, you should be looking for the opportunities within the ecosystem. But largely think of it like there was I forget this. I think it's Dronacharya, but I'm not be 100% sure of this. There was someone who started building drones back in 2011 when drones were not the big deal, right? They were not the trends, right? Back then, everyone would have thought, let's jump into investment banking maybe. Right? 2011 was when the person started building things, and 2021 when he's among the biggest drone companies in India. So think in those terms. Once you do things that are really to your passion, and then you start building expertise, like you can get a doctoral degree, like what Ajit said, like build expertise, right? Build expertise can happen multiple ways by doing hands-on, trying different things that work. Working in India, for example, works perfectly well too. But you better be focused on the doing part rather than purely like, let's speculate, let's go and get the next gold rush, right? That's not going to happen. Have confidence in yourself, build for it, do those things. A decade later, the world changes, you change, and then the right culmination of when you and the world meet, things happen, right? And that's how you should be looking for every activity you do. Think in those lines. I think you should develop expertise. I'm not too well aware of the hardware market too, but maybe build something, see how these markets are. If you're purely entrepreneurial, try that way. If you're a little bit more researchy, try for like PhDs, doctoral degrees, get expertise in this space and see how this world explores. But keep building, keep doing. That's the only way to be successful.
Thank you, Vibin and Ajit. Our next question is about VLSI. So students are quite interested in pursuing their career in VLSI. So they want to understand what are the steps and how do they take it forward? Because many of them are from electronics, chemical, civil engineering. So what is the way forward to pursue a career in VLSI? Like designing, testing, etc.
So Vipin, you want to take that or you want me to?
Yeah, I'll give a first pass shot at it. If,
Right.
Guys, my understanding of VLSI is peripheral only from what I heard from like working in the fabs when the designs were handed out to us. Like when I was there, I was an engineer building out stuff, not really building out the design for it, right? Or but I can tell you this. So based on my interaction with a lot of people in that space, right, the fundamentals are still the same. So VLSI, nothing much has changed. I know that, like, for example, Synopsys, the big EDM company, engineering, design, and manufacturing company, just bought out Ansys, right? So, and why it bought out is there's a lot of like matching of interests, right? There's a lot of simulation packages that they do, a lot of new interest in AI ML into decreasing simulation times. So it all makes sense. So, but really, if you think about VLSI design, I'm sure there's going to be a little bit of like front end of it, back end of it. There's going to be things related to the different solutions that's part of it, right? You have to focus. That has not changed. Some of these tools are very expensive. Like I think Verilog and stuff, you would not be able to program into it till you have, for example, access to it from university or from the companies. So you need to be part of the ecosystem. You need to work over there. Your knowledge of, say, algorithms, right? The different compute systems that go in, the different blocks that build in your electronic circuits, that's going to be fundamentally same. Like I remember there's a course which was taught in I think the early 2000s. Okay, this is from IIT Kharagpur course. Even now, that's the most sought after course for learning about computer architecture, right? So it's a very outdated system, but the same outdated system is going to be the ones that help you understand how these blocks fit in and how the logic flows. In fact, it's easy to build up from the ground up, right? From a simpler system, you can build up complexity. You can't directly jump into complex systems. Things have become, like when Ajit talked about that multi-layered NAND, it's got extremely complex, right? It's going to think about how are you going to connect those different layers. So there's going to be interconnects, there's going to be vias, ducts, and stuff they're going to build in. It's a nightmare. When looking at it, I'm just shocked at kind of technological growth that has happened, right? But those are going to be engineering problems. But the design part of it, there are going to be tools, there are going to be simulation softwares that are going to build it, and you're going to be aware of it. But the fundamentals are not going to change. So the VLSI program has like there's different IITs offered these VLSI courses and programs. Like you're gonna go or any university, right? Doesn't matter. Or even online, you could get books and materials. But read the material, be good in your core content, have opportunity to work in industry to actually have access to the tools, because those tools are not cheap. You can't even get them pirated, right? So it's gonna be something that you'll have to gain real expertise on. Once you have that, I think you have enough of the material there to be successful. There might be specialists to tell you exactly, like you can find material online who tell you what exactly the paths and stuff to take. But in general, this is what it is. Core technical knowledge, get some expertise. The fundamentals are still the same. Like it's not going to change.
Yeah, just to add to that, I think you gave a very good response there, Vibin. So a couple of things to add to it. One is these days there are concepts of shuttles where people build test circuits for you. For that, you have to be part of a group. So I think you've got to identify which group is working on it and somehow figure out how to become a part of it, put part of your design in that. And there's no substitute to learning by doing, right? That's what Vipin mentioned. So if you build something, you build it and you actually test it, you get the results. So that's one aspect of the VLSI design. But another aspect is putting together a process design kit. So I talked about the circuit itself, or these structures. But ultimately, that has to be codified in some way that goes into a design tool. And for that, you have to have a clear understanding how VLSI design works and how the process end works, because the two have to meet. At the end of the day, these designs have to be executed in silicon. So whatever has to be designed must need design rules. And the design rules are extremely difficult to obtain and require tremendous amount of expertise. So if you're interested in VLSI, and some process technology, then the intersection of the two is trying to put together the process design kit. And virtually every fab, whether it's a foundry or IDM, has a huge group dedicated to process design kit generation, so that designs that come out from the VLSI groups or ULSI groups can actually be manufactured with good yield. And I think that's a very important aspect. So you could learn and expand your expertise in that area as well. Thank you,
Ajit and Vibin. So the next question is it better to get deep into core in electrical engineering alone, or along with electrical engineering, is it better to do computer science courses? I think this is one question multiple students have asked. Can I do an AI ML along with electrical, electronics, or should it be only my core?
Ajit, I'll go for it because it's something that I can do. So again, guys, I'll give you an example where when I was working with AWS IoT, I launched a LoRa WAN. So LoRa is a long-range network. It's not regularly your TCP/IP network. It's a very different network. So you'll have to build stacks for it. You'll have to have devices for it. Pull these different teams together to actually deliver something. So aware of a little of what this means from multiple perspectives. So one of the things that is going to happen in life is that different technologies, people, communities are going to come together to actually build real world projects, whether it be the things like the digital twin, or it's going to be some AR devices that Meta is trying to sell, or now recently Apple brought out, right? These are not going to be just because of electrical engineers, or this is not going to be just because of, say, a physicist to actually build out, or maybe mechanical engineers. It's going to be a group of people coming together. There's going to be a lot of computer science involved in it to actually make these things happen. But that said, you are not, in that work, you're not going to be the person building everything. You're going to focus narrowly on one part of it. Either you're going to be a device engineer, you're going to be a software engineer, building out the network stack. You're going to be the guy who's involved in ensuring that the data gets stored. Maybe you're the person ensuring that the backend is not compromised, those kind of things. So to your question, I guess fundamentally the question is, what, based on your awareness of the world right now, and based upon things that you have done, how comfortable are you with, and what is your aspirations, right? Like a lot of people say, hey, should I look into coding? Coding is for being a software developer is what people mean by coding. And so being a software developer is, at least in a very traditional sense, is not that interesting, if you put it that way. It's purely writing a bunch of code for a certain feature. If you look at from your space of like electronics, should you know coding to actually do it? Yes, there's going to be different things, right? Is it going to be the registry level code that you write? It is not like anything on a language level. It's not like C or anyone else that you would write to. But there's also going to be embedded code that you write, maybe based upon Linux, maybe based on C, that's actually going to go ahead, fit into ensuring that the device works the way it's supposed to work. So those are core things required for your engineering knowledge. So you need to know deep about how to put these things together. There are a lot of people working on embedded devices. It's an active group, and if that's the interest you are working on narrowly in that region, you would need to know enough of it. Should you know about simulation techniques? Yes, from the perspective of how do you use it to actually go ahead and get value from it. Should you need to know about deep learning technologies to actually do? No, because there's the idea of abstraction. Everything we do is abstracted away. You don't need to know the lower level details till you need it. So I suggest this is the process you apply for learning. So when I jump, like right now, when you say like at a certain stage, you can build anything. I can build a rocket to the spaceship. It doesn't matter, right? It's the same process you would follow, which is you bring a group of experts, you would work with them, try to understand what are the constraints, and then individually you will try to narrow it down to what you want. So that's the space you would need to be in. That is, knowledge comes from taking up what you want at a theoretical level, and then working on into parts of it that you need at that point of time. So right now, based upon interest, what are the things that you need? If you're going to be an embedded systems engineer, there are certain set of skills required related to software too that you need to have, which you need to develop. If you're going to be someone, let's say, looking at signal processing and stuff, you need to know a lot about transformation techniques. You need to know about some things about MATLAB, Simulink, and those kind of things. And it stops over there. You don't need to know about like lower level, maybe how data structures are made, how it is stored, how it's transformed, maybe how operations do it. Not necessary. You could have. It's fun to learn a lot of things, but you don't need to know that. What you need for a success is very limited, right? But as you get into a project, you should have that ability where you should be able to pick up things on and when you need it. So have a very strong fundamental out there with you. Have a very strong learning agility. Don't say that this is not my scope of work, I would not learn it. It's interesting. Everything in the world is connected in some ways, right? It's logically trying to solve a problem. But if you keep that mindset, you can pretty much pick up everything as and when you require, and you will not overburden your mind with things that you don't need. So narrowly now, based upon what you know, think about the market for electrical or electronics engineers, and think about what kind of jobs are interesting for you. Look at the job description of companies and see what are the skills required. Be prepared for those skills. Don't do more if that is not required for the jobs. You could do more as more of a hobby, but stop at that level. You'll be successful, right? As and when you need more, just pick up more. I'll stop here.
So just to add to that, I think, each person needs to identify sort of a little bit of a career path and the core competencies in which they think they're going to be very strong and differentiated. So those you have to develop. So that's pretty important. But the other part is you need, of course, need all the other skills that go along with it to be successful in that core competency. It might require software, it require material science, depends on which sector you're in. So those skills you have to develop. Now, as you advance in your career, if you want to be a technical specialist, that's one thing. But if you really want to define how technology is going to advance in more, technical management roles, by definition, you have to get a working knowledge of all the associated disciplines. Doesn't mean you have to be an expert, but you have to know what questions to ask and whether the response given to you makes sense or not. If you cannot ask the right questions and you cannot assess if the response given to you makes sense, it's going to be very difficult to advance in a technical management role. So I would not, and learning is always exciting, but learning in abstraction is sort of useless. So you have to be dynamic, you have to be agile, you have to be ready to learn and learn broadly. Doesn't mean you have to be an expert in everything, but you have to know at every stage in the game what level you need to be prepared. So people know that they just can't flip over you and go ahead. You'll be watching over, and you can manage them. You can also set expectations and the vision appropriately based on your own experience. So I think those are the other important elements to consider.
By the way, get work experience, guys. So nothing beats it. Real world actually transforms all these theoretical questions into real questions. You get work experience, nothing else. Startup, free internship, doesn't matter. Just get experience. It'll teach you a lot.
Thank you both. So the next question is about startup, regarding how do I really go on with the startup, because I am interested in that, and how do we get the initial investment? How do we grow our network? Some of the suggestions and techniques from successful startup people who tackle this ever-changing market.
I can take it. Been involved in a bunch of startups now. Many of them not so successful. One hopefully going in the right direction, right? The biggest thing is actually what is the value add you're doing, right? There's a mythical thing called the product market fit, which is what service you offer and what people want should match. Only then there's a value in the market and things would come. But that's a critical thing. Find out what is the value addition you do. Don't think about like I want to be a billionaire, right? That's the wrong way to approach the problem. Think about like what is the need in the market that addresses by your solution out there, right? Think about a problem first, and then think about how would you go build a solution to it. Okay? Part of the problem is most people do not have a problem to solve. They have solutions to offer, right? You may think very abstract, what is this? But it's like everyone wants to, let's say, sell a pen. Nobody wants a pen, right? There are enough pens out there, right? Or if everyone wants to set up a restaurant, there are enough restaurants out there. Why should they come? Think of it like what value addition you do, and then think about how things all change. But that said, startup is not so linear, guys. So let's say it's an intersection of a lot of things that happen. You should firstly be in a position to actually manage. Startup life is really, really tough. If you think working as a manager is tough, startup was 1,000 times that. So there's all the pressures in the world turn out to be you. And also there's a lot of things, there are a lot of things that are happening behind the crowd too. Like to raise money, you do a lot of things like raising money by taking money from people, and people don't give it. Nobody gives, like, I don't give you money for free. You don't give me money for free, right? A lot of demands associated with it. You be in the position to handle a lot of things. So I guess there's a maturity required to be into this kind of things, which is underestimated. And if you don't have that maturity and that vision of what this entails, what kind of sacrifices it means, it may sound very romantic early. Say I'm a startup founder, I'm the CEO, CTO, whatever it is, right? It's very romantic. It sounds very great. It's like that. It's like the stories in the movie where the hero goes on an adventure, right? Adventure is necessarily bad, where you get hurt, right? So you need to have the maturity, you need to have the resilience, and that comes only through real world experiences. So and most of the startups actually do badly because of really bad people at the helm. They're not bad per se. It's just that they're too immature to handle that kind of work. So they end up being a bad experience for everyone, right? Doglapanti guy, you should know who I'm talking about, right? But these weird things happen. So firstly, get experience, be a nice human being first. Learn about yourself before you go and change the world. To do that, then get solid experiences, be in very challenging situations, see how you respond, and then think about like technology is not the solution. Value and how you deliver the value is going to be the challenge. So understand yourself first before you jump into the world. For that, get some experiences.
So just to add to that, I think the word experience is extremely important. I found in my career that working at Texas Instruments, I was working with the who's who of the electronics industry, and you finish a degree, you actually know nothing about the real world. And the only way you're going to learn is from learning from the experts. You have to stand on the shoulders of giants to get to reach for the skies. You cannot be on the ground reaching for the skies. You have to stand on the shoulders of giants. So getting that experience from world-renowned people who are experts in the field, knowing how things are done, will give you a broad perspective. I know once you get into that world, it's difficult to go back into the startup world, but if your mentality is to do startup, learn first before you take the plunge. That'll also give you a much broader perspective of how to manage people, how to assess the risks, how to assemble the right team, and the team that you'll hire will respect you. If the team that you hire does not respect you, you're going to be bound for failure. So you've got to be able to hire people who are actually better than you. That's extremely important, and people will only do that if they respect you, because they know that you're very good in one area and they'll come and compliment you in some other area. And that you can only get through experience and proof that you've been there, done that.
Thank you both. So we are running over time. So let's have the last question for the session. It's from Gautam, who says, I have a keen interest in design and manufacturing in the automobile industry. So how should I go further about it to my desired field? So there are a couple of questions related to industry automation and automobile industry. So if any of you would like to take that question.
I'll go first again, but it's going to be similar. Like it's just one, like I would say the same thing for design or for materials, for example. It's going to be the same things for a specific industry. Automobiles is one example. It could be design of materials for electronic industry, or how do I go build new designs for electronic industry? Just replace one X with Y, you will get the same question asked across fields. A few things here, right? First, you should understand the technologies really well. You should have some experience with it. And then go about building more experience related to that. That part 3 requires you to have, so it almost seems like counterintuitive. I need to have experience to get more experience. To do that, so first reach out to like startups, reach out to faculty, do projects where you can to actually start designing systems, right, for your automobile parts. Be part of competitions. There are a lot of competitions now, like for different challenges, like autonomous vehicles competitions and stuff. You should be there. I saw IIT Madras had recently F1 a car built for F1 race, right? So those kind of things. You should be part of such teams. How do you get into it? Reach out to people, talk to people. That's why I said the kind of work career you build is pretty much on your hands. So you need to build expertise, you need to build experience, and to do that, you need to start actively reaching out. LinkedIn has opened up an entire community of people. There are your seniors out there from your universities. There are people like Ajit. There are people here on this call who are like very well versed in their field, right? You might want to reach out to them. Sometimes they will respond, sometimes they may not. But if the time is right, if you're lucky, and if you use the right way to reach out, you'll have an opportunity that opens up. Part of the things actually that happens in life is people don't do the reach out, or they do in a very, let's just say first you don't reach out. Most people don't reach out, they're too frightened. I say reach out, create the opportunities. You will be surprised how opportunity reach out. So get practical experience, and to do that, network, reach out, build your own core expertise, talk about how you add value add for the project you're trying to do, and then take it forward. Be respectful in all those things. There are some nuances, but reach out, build the experiences, and leverage that to get more experiences. In general, very broad, but if you want to talk more, I think we can have a separate talk on these two.
Yeah, I think the only other thing I would say, in something like this, you have to bootstrap, and you have to really actively figure out how to bootstrap. And that means looking at what others have done, where the problems are in the field, looking for teams, looking for other projects, and you've got to weasel your way in. And typically, if you're interested and you've shown a passion for something, you can get in. And it may not be an easy step, but it's a price to pay. So for all of these things, don't imagine that it's just going to be an easy step. There's going to be a price to pay. And you have to be willing to pay that price. and then the rewards will be there. So I think that's what you have to do. Just have to make sure that the industry or sector you're getting into has a future. If the industry doesn't have a future, whatever you do in it, it's going to be hard to succeed. When the industry has a future, it's growing rapidly. If you're able to do something that adds new unique value, you'll grow with the industry, and it'll be a good journey for you.
One final note here. There is never in your life where you'll be more ignorant than you are now. The next day is going to be you'll be with more knowledge. So think of it like a wonderful opportunity where you would never hit those kind of the places you would be ever again in your life. So when I began my career, doing that kind of jobs, working like there are times where I worked in the fab for like 52 odd hours at a stretch. I never ever had to do that again. But that was experience only at that point of time. That was available only there. Now nobody would ask me to go and work in a fab for that many hours, right? It's an opportunity. So think of all these steps as like a fantastic path. It may seem like not so fantastic at that point of time, but it happens only once. It is the opportunity of a lifetime that is staring at you. The levels of the unknown that faces you will become less unknown when you go into the future. It becomes less challenging, less thrilling, if you would, right? Now is the best way to face the world with whatever magnificence it has, right? Be in that mindset and understand this is a fantastic world with fantastic opportunities. You just have to be in the right mindset. Things will just work out for you. I know it's hard. Economies go up, down, life changes. But remember, it's not a journey of your life, it's a journey of yourself. So it's a little philosophical, but that's pretty much all there is. So enjoy your journey. It'll be fantastic for all of you. I know it will.
Yeah. Good luck to everyone.
Thank you, Vibin and Ajit, for this wonderful session, and thank you for joining us today. I'm sure it was a pure delight listening to both of you, your insights into industries and technologies, the emerging industries. It was very inspiring, informative. I'm sure the students had a lot to take away from today's session. I would also like to thank Vinod and Maya for joining us and being with us today. So thank you, scholars, and have a wonderful day, all of you.